Thank you for tuning in to our channel, our academic channel. I'm back for mathematics once again, and my name is still the same. It has never changed. I'm Hamza. If you want to call me Ruwama, I'm Ruwama Hamza. So here I am once again to take you through mathematics. Big up to Newman's Foods. Newman's Foods has sponsored this episode. Big up to him. For whoever wants to have some crunchy, tasty snacks, foodstuffs for packaging to school, to tours, look out for Newman in all supermarkets in this country. So with that, I'm going to teach a concept actually which Newman uses as well. When we are eating, we use a concept called differentiation, because whenever you're reducing a term, you're differentiating that term. So as we differentiate the crisps, the different snacks of Newman, think about differentiating numbers as well. So today I want to talk about differentiation of trig functions. Differentiation of trigonometric functions. In this case, we are going to realize the following. That one, we are going to have a trig function, for example, function y, which function y can be in the form maybe sine to the square of maybe bx. And one of the techniques of differentiation is to let. You can let, for example, you can let the angle, anything, change. But the technique I want to use or to borrow today is the technique which I'm going to call PTA. PTA is a technique that is going to be used to first you differentiate the power. So if this power was any other power, for example, sine of n of bx, if I want to get dy dx, I'll need to first differentiate the power, which is n, sine, the power reduces by 1, keeping that angle the same, times the derivative of the trig function. The t stands in for the trig function. When you differentiate sine, you get what? Cos of the same angle, times the derivative of the angle. When I differentiate bx, I'll get b. In actual sense, the derivative with respect to x of sine of n of bx is going to be equal to nb sine of n minus 1 of bx times cosine of bx as the solution. With this, I am borrowing the technique I'm calling the PTA technique of differentiating trigonometrical functions. And these trigonometrical functions, we are going to see the different examples, and we see how they can be handled using this skill of PTA. So, allow me to take you through to example 1. If I take you through example 1, we can have the following. Examples 1. Differentiate with respect to x sine cubed of 3x squared plus 1. So here we are. We have a trig function we are differentiating. It has a power, it has a trig function, it also has an angle. So borrowing the skill of PTA, we shall say d, I can let y be equal to sine to the cube of 2x squared plus 1. So that dy of dx is going to be equal to, first differentiate the power, you get 3. Sine, the power reduces by 1, which becomes a 2. The angle is still the same, which is 2x squared plus 1. Times the derivative of the trig function, you get cos when you differentiate sine, which is of the same angle, 2x squared plus 1. This is 3x squared plus 1. Then lastly, you differentiate the angle. When I differentiate 3x squared, the answer is going to be 6x. So I will have to multiply the 6x with a 3. So the result becomes 18x. Then I'll have sine squared over 2x plus 1 times cos of 3x squared plus 1. And that will become our solution for such a problem. We have differentiated the function y, sine is sine cubed of the angle in the bracket, which is 3x squared plus a 1. Let's look at example 2. Differentiate y is equal to tan to the power 8 of 6x to the power 4. In this case round, still using PTA, there is a power. Yes, we shall differentiate the power. There is a trig function. We shall differentiate the trig function. There is an angle. We shall differentiate the angle. So dy dx will be, first differentiate the power, you get 8. The power has reduced by 1, making it 7 of the same angle, power 4, times differentiate the trig function. When I differentiate tan, I get sec squared of the same angle. Times differentiate the angle, you get 24x to the cube. It is from this result that when I simplify, I have 24 times 8. 24 times 8 is the same as 24 times 4, which is 96. 96 times 2, the answer is going to be 192. Because 96 times 2 is 180 plus 12, so 192. So the result will become 192 x to the cube of tan to the 7th of 6 of x to the 4th of sec to the square of 6 of x to the 4th. And that will be your solution. Okay? Then other cases also can be in this case. Y is equal to cos of 2x minus 1. One may say, is there a power? There is no power. Actually, there is a silent power 1. So we need to think along that line and think outside the box. There is a silent power 1. So dy dx will be, when I use PTA, the power is 1, so I'll get 1. Cos to power 0 of the same angle times derivative of cos, you get a negative, sine of the same angle minus 1 times the derivative of the angle 2x, you get 2. But any number power 0 is 1. So the result will become dy of dx is equal to 1 times 1 times a negative sine of 2x minus 1 times 2. So the final solution will become a negative 2 sine of 2x minus 1. So in that regard, when I'm differentiating cos of 2x minus 1, it's the same as differentiating the angle and only differentiate the trig function. Because the silent power 1 which is there will induce a power 0, which power 0 is always a what? A 1. So to minimize all that tasks, all those challenges, of all those hassles of writing a lot, you can just differentiate the angle and the trig function and you get the answer. So using the PTA technique, you look out for what is present. If the power is missing, you neglect the power bit of it because it will induce a power 0, as I've showed you. Then in case there is a trig function, go ahead to the trig function straight away. Let's look at example 3. Example 3, you can be given y is equal to tan inverse of x squared. And they ask you to find y dx. Here now it's an inverse trig function. That's when we need to bring in the knowledge of trigonometry and think carefully and first design something similar to what we have seen in the earlier examples. So in case you want to get the tangent of y, it is actually equal to x squared. So I'll differentiate both sides. When I differentiate tan of y with respect to x, I'll also differentiate this side of x squared with respect to x. When I differentiate tan, I get sec squared y. Because it's a singular tan with power 1, differentiate the trig function, you get sec squared of the same angle. Differentiate the angle y, you get 1. So here I have differentiated y with respect to x. So whenever you differentiate y, and yet you are trying to look for dy dx, we attach a differential coefficient, because it means this side you differentiate it as an implicit function. That technique comes from what we call implicit functions. If you check out in some of our videos, you'll find those videos which have some of those definitions of the earlier techniques of differentiation in Backhouse 1. So, whereas when I differentiate x squared, I get 2x. Therefore, dy of dx, the answer is going to be 2x out of sec squared y. But from trigonometry, sec squared y is always 1 plus tan squared y. And yet tan of y was x squared, so this is 2x out of 1 plus x. But the x was squared for tan, and it is squared again. So the final solution will become dy dx is going to be equal to 2x divided by 1 plus x to the fourth to the power 4, and that is going to give us the solution for the derivative of y is the tan inverse of what? Of x. So we can also think about the same questions and ideas along the same line, but maybe to remind you a little, I need to give you a recap of the obvious derivatives. For example, the derivative with respect to x of tan of x, this one is always sec squared of x. Then the derivative with respect to x of cot of x, this is a negative cosec squared of x. The derivative with respect to x of sine of x, this is cos of x. Then the derivative with respect to x of cos of x, this is always a negative sine of x. Whereas the derivative with respect to x of sec of x, this one is written or gives us what we call sec x tan of x, whereas the derivative with respect to x of cosec x, this will give us a negative cosec x cot of x. So before one goes for derivatives of trig functions, you should always remember these general definitions of those key 6 trig functions. When differentiated, what do we realize? So with that, today we have looked at differentiation of trig functions using the technique of what we have termed as PTA, and the episode has been proudly sponsored by Newman Foods. Big up to Newman. And whoever feels like needs to get more examples on the same, we shall attach numbers which will be looking at some of these categories. We shall have more examples coming through and more other techniques with time. But if you keep it here and you keep logged in, keep subscribing to our channels, trust me, you'll always see all those different techniques and definitions as they will come through. Once again, I'd like to thank everyone who has always joined us and watched our videos and shared them and liked them and subscribed. You're doing a very great thing to this world. You're doing a very great thing to the world of mathematics and science. I'm still Hamza, and I would like to thank you and say goodbye for now.